All right, good morning, everyone. For folks who just came in, is it raining out there yet? Yeah, I think we all got here just in time. It looks pretty bad. So really pleased to welcome you here on behalf of the Chautauqua Science Group and the Chautauqua Climate Change Initiative. My name's Mark Wensler. I direct the Climate Change Initiative, and I'm really pleased to be collaborating all summer long with the Chautauqua Science Group on a really great program of speakers. And I'm super excited that we have with us today John Atkinson from University of Buffalo. John's a professor of engineering sustainability and an expert on recycling. I know that's a topic that I get asked about almost on a daily basis here at Chautauqua. Like, why don't we recycle more? What can we recycle? Are they really recycling? What's really happening with that stuff? And so the good news is I don't have to answer any of those questions because John will answer all those questions. So, we're going to put him on speed dial from now going forward. And no, I'm just kidding. But it's really an important topic. It's so central to what we're discussing this week. And we're going to get a bunch of different viewpoints on that. I will say I want to thank Rachel Zoe Miller, I see is here. She is our speaker this afternoon at 12:30 in Smith Wilkes. So please come see Rachel launching her new book today at 12:30 at Chautauqua. This is the second book launch at Chautauqua. That's pretty cool. And so, John, we're so pleased to have you. You did a great job yesterday in our panel discussion on the reuse economy. I think it was, anybody here yesterday for that? Yeah, it was great. Yeah. So clearly you made an impression. And I really look forward to seeing you here, and welcome.
Okay, well, thanks for coming back. You never know. Yesterday I got to be a bit more philosophical, I suppose, in my thoughts on sustainability and waste. I'm approaching today like a class. And what I often do in my classes is start with a pop quiz. And we got to do it right at the beginning so people coming in late get a 0 on it. So we're gonna start with that. And then I'll introduce myself and things like that. So this quiz is called Does It Get Recycled? Okay. Number 1, does it get recycled? Cardboard gets recycled very, very efficiently, 95+%. You put it in your bin, it's essentially a guarantee that it will get recycled and likely turned back into cardboard boxes. Cardboard can get recycled 7 times. So every time you recycle it, the fibers get a little shorter, a little shorter, a little shorter. And after about 7 times, they get so short, can't be recycled anymore. They usually turn it into like animal bedding or something like that at that point. So even then, it does get another reuse. Now, what do you do with these boxes? This isn't just cardboard, right? What else is there? Plastic. So you got tape, you got labels, all of those are plastic. You don't have to remove them. If you can, go for it, but you definitely don't have to remove them. What happens when they bring it to a cardboard recycler is they shred it into a pulp, and the cardboard sinks and the plastic floats. They skim the plastic off the top and usually burn it or something like that. We'll talk more about plastic. Okay, so cardboard, good. Question 2, does it get recycled? Ooh, controversy. This is why I'm here. What's the difference between this and this? Wax. Yeah, so this cardboard also has plastic on it. But what's the difference between this plastic and the tape and labels? You can't peel it off, right? You can sit there and scratch all day, but that plastic isn't going to come off. Most recyclers throw this away. So for me, if I pull a box out of the freezer, it goes in my trash can. Pizza boxes, ice cream boxes, big cardboard boxes that you want to recycle. I don't put them in my recycling bin. The first time I ever went to a recycling facility, which really wasn't that long ago, maybe 10 years or so ago, I'm walking through and there's just a pile of cardboard. And I remember very naively asking, like, what is this? And they said, well, that goes to the landfill. This is card. This is the one thing I thought does get recycled. And they said, no, the waxy cardboard is very, very challenging to recover And so most recyclers, it's not all, but most recyclers throw this material out. Question 3. Glass. The first thing I'll tell you is if you speak to somebody that runs a recycling facility and you say, what's the most problematic material? If you could take one thing out of your waste stream, what would it be? Every single person will tell you glass. What happens to glass? You put it in your bin. It breaks. It breaks. It's sharp. It's the reason why workers have to wear big gloves and lose their dexterity. It rips up the conveyor belts because it's abrasive, obviously. And the other issue with glass is that most recycling facilities, the very first stage of separation are little screens, and they call it the 2-inch rule. Anything smaller than 2 inches falls through those screens, goes into a pile, that goes to the landfill. So broken glass is almost always going to be smaller than 2 inches, fall through the screens, and go to the landfill. So glass is problematic for a lot of reasons, but municipalities love glass in recycling. Anybody have an idea why? It weighs a lot. And so usually recycling rates, when you read, my town has a 31% recycling rate. Buffalo, when I moved to Buffalo, we had billboards that said 34 and more. The goal was to get a 34% recycling rate. That's entirely based on mass. You pull glass out of the system, plummets. You know, probably half the weight, maybe more, is glass. And so glass is sort of a controversial material. Now, we have bottle bills in New York State where, in theory, that glass bottle doesn't break. Sometimes you hear it breaking, but sometimes it doesn't break. Glass is actually one of, if not the easiest to recycle material. You just melt it, you turn it back into glass. But colored glass like this is challenging. It's hard to separate green from clear from brown. And so it just becomes a challenge, glass. Most glass at most recyclers goes to landfills. So glass is a painful one for anybody that works in recycling. There are creative people coming up with different lasers and things that can sort the different colors. But at present, most glass goes to landfills. Yeah.
When I was a kid, my grandparents used to get rolling off beer, and the bottles would go back.
And in most countries, that occurs too. So I spent a lot of time in Costa Rica teaching study abroad courses, and I should be quiet. Sometimes I go to the bars. Drinking age is 18 in Costa Rica. Everybody's legal. And inevitably, they have the crates that the beers came in, and when you're done drinking it, you put it right back. The U.S. used to do that, as you say. And then the Department of Health stopped it. So they deem it not sanitary, not able to clean those bottles for reuse. And so we take glass, we break it down into powdered glass, and then we turn it back into glass, which doesn't necessarily make a lot of sense from an efficiency perspective. And maybe that'll change at some point, but right now we can't direct reuse glass bottles. Those do get reused. Yeah, reused directly, so not broken down and then brought back up, but reused. Sorry, I get going and then I could just said. Okay.
Yeah, thanks, folks. We'll just, nobody else can hear your questions, so we'll wait till the end, and then people will come up to the mic. That makes it better experience for everyone. Thanks.
Okay, perfect. I'll keep rolling. Okay, so glass, not so good. This is my favorite brewery in New York. It's called Other Half. They started in Brooklyn. Now they're all over the place. But does aluminum get recycled? Yeah, aluminum is like or maybe even better than cardboard. Okay, and one of the reasons why is because raw aluminum is incredibly expensive. And so more or less, anytime you have a can of Coke, can of beer, whatever it is, that's recycled aluminum. It can get infinitely recycled. It's a very efficient process that works very, very well. What about those labels? They're plastic, often they're PVC. Do you take them off? Sometimes I sit at bars and I take the labels off beer cans and I just look like I have really high anxiety. And I do. But so the first thing that happens to aluminum is it gets melted, really high temperatures. So any plastic will burn. So leaving the label on will not affect the aluminum. But aluminum recovery facilities have very strict air pollution rules because they're burning a lot of PVC, because the PVC is on the cans. So it does help the recycler if you remove the label, but it's absolutely not necessary. It's kind of like the tape on the cardboard boxes. The other issue with removing labels is you need the barcode for bottle deposits. So it doesn't, if you want your nickel back, you can't take that label off. So let the controversy begin. Yeah, so PET, number one, plastic number one, does get recycled, okay? What it gets recycled into is variable. It might not be into a food container that it started with, but PET in general does get recycled. The bottle here is PET, the label and the cap are probably HDPE. So number one for the bottle, number two for the other materials. Anybody know how they get separated? In the back. Sink float. PET is very dense. It sinks in water. HDPE is very light. It floats on water. So they literally shred it into pieces, put it in a tank of water, and then skim the HDPE off the top and collect the PET off the bottom. What they do with that once it's recovered is controversial. Coke has been sued with people saying that the caps and labels don't actually get recycled. And sometimes there's not buyers for that material. That can be true. The PET, though, usually will get recycled. Maybe the better question is, how do you recycle something like this? Grocery stores. Plastic bags should never go in your recycling bin, unless you live in New York City where you're, I believe, required to bag your recyclables. But in most municipalities, plastic just, second to glass in terms of most problematic materials. It tangles everything up. They literally call them tanglers at recycling facilities. So you should collect them with your newspaper bags, with whatever other comparable plastic materials you have. Put them in a bag, take them to Wegmans, take them to whatever your Home Depot has to collect these. There's lots of rules in the state on who has to collect this stuff. Bring it back there. It probably will get recycled. But it's a totally different path than what we're used to. I'm going to focus on the curbside stuff today. LDPE, this is number 3. This can get recycled, but it is a more complicated pathway. You can't read this, so I'm going to go through it quick. But we, my group has done lots of studies on retail return recycling. And I just want everybody to know that what you can put in those containers is not just plastic bags. So e-commerce bubble mailers, so you get that plastic blue and white envelope from Amazon, those can go in retail return bins. Bread bags, those can go in retail return bags. Dry cleaning bags, those can go in retail return bins. There's a long list of stuff that can. Now I will say again, you can't read this, but there's a longer list of things that can't. Okay, but in general, you can look this up exactly, there's even tests you can do with your thumbs, can you push your thumb through it with a reasonable difficulty? Does it tear or sort of pull apart? Those will kind of allow you to figure out what can go in those retail return bins. Cereal bags, those actually are recyclable, and things like that. Okay, so hopefully you passed. That was our quiz. That's what we're starting with. Thank you for having me back, Mark, Science Group. Really an honor to be here. I'm John. I'm a professor at UB. I study waste management in many different shapes and sizes, but what I'm talking about today is the recycling system. So I was asked to discuss what's going on in the recycling world, and whether or not it's improving. So I want to just begin very frankly. This system is not broken. Recycling works. It does not work perfectly. There are many places that it can be improved. And there are many people that are thinking about how to improve that. So I'm going to tell you today how it works and what's being done to try to make it work a little bit better, going through the whole system from consumer to reproduction. Okay? I'm going to do it fast. There's a lot of information here. It's much more, it's not super technical, but it's more technical than I was yesterday, certainly. And then we'll have time for questions at the end. Okay? I'll leave at least 20 minutes or so for questions. Good? All right, awesome. So, we're talking about improving. What the hell does that mean? How do we define improving recycling? Is it that recycling rate number? I mean, if I throw a cinder block in my recycling bin, recycling rates will go up. Literally. I mean, they base it off the weight that's measured when they empty your bin and compare it to the amount of trash that's measured when they empty those bins. So recycling rates are easy to manipulate. Again, glass is what makes them as high as they are, and most glass doesn't even get recycled. But ultimately, when we talk about improving recycling, this is an economics problem. I said this yesterday as well. This is all about, can we make money? Can we make more money? Or in some cases, can we make some money recycling? The margins on recycling are incredibly low. They're incredibly low. This is like, wake up one day, today we can recycle this material. Wake up tomorrow, today we can't recycle that material. I was talking to somebody yesterday that works in the industry. They said one company closed. One company in the U.S. closed, and that plummeted the price of PET. And PET is one of the good ones, okay? And so the industry is very, very complicated. But if you want to talk to people that are sustainability minded, that want to work on waste management, that want to help fix these problems, speak to somebody that works in recycling. Okay? They are not bad guys. They are working to recover materials and to create a system where everybody benefits. Okay? They're not the oil companies. They're not the bad guys. We'll talk about them a little bit. But in general, the recycling system works. You should recycle. But I and many, many other smart people are trying to figure out how to do it a little bit better, how to get these numbers a little bit higher. But ultimately, anytime we're talking about improving recycling, we are talking about decreasing the price of recovering recyclable materials or increasing the price of the products that are made with those recycled materials. You know, basically making the final product more valuable. So whether it's education of consumers or fancy sorting technology, it is all motivated by money and trying to make that final product more valuable. So the companies that recover it can sell it and make a little bit more money off of it. Okay, this is what the system looks like. It starts with you and me. We are an essential piece in this puzzle. I visit recycling facilities all the time, and I always ask them, what's the craziest thing you've seen? And they will tell you everything. Deer carcasses, cinder blocks, weapons, everything. Not just like, oh, they put the wrong plastic in. No, crazy stuff. This is not a place to get rid of your shit that nobody else wants. It frustrates me to no end, but it is an interesting conversation. By the way, I encourage you to visit your local recycler. More often than not, it's not totally an open door policy. You probably have to schedule it. You can't just knock and show up. But go with your kids, go with your grandkids, whatever it might be. It's really an interesting experience. And again, these are people that want to show off what they're doing. They stand behind it. They believe in it, and they're proud of it, and they will give you a fantastic tour. Just don't tell them I sent you. Okay? Okay, so it starts with the consumer. You choose what to put in your recycling tote. Then somebody picks up that tote. It might go to a transfer station depending on where you live. If you live in a small town and there's small trucks, They might go somewhere to kind of consolidate everything and put it into a bigger truck. But ultimately, it's going to go to a sorting facility. At that sorting facility, you're going to have automatic methods, and you probably are going to have manual methods. Okay, I live in Buffalo. We have a pretty big facility. It's a pretty big city. They process lots of materials. Most of their plastic sorting is by hand, which is somewhat shocking to see, I think. I mean, it's just, they're super fast, and they kind of have 5 bins around them, and okay, that one goes there, that one goes there. And the line is moving. I mean, it's a fast process. So obviously some opportunities for improvement there. Ultimately, what leaves the recycling facility is what's called a bale. It's a big cube of material, usually wrapped with like a metal wire. That's what gets sold. Another hauler comes and picks it up. They take it to a reclaimer, and the reclaimers are the ones that remove the impurities. So all of this is about contamination, right? The sorting is separating out the materials as best as they can so that you got pure aluminum, you got pure steel, you got pure cardboard. And then the reclaimers are removing that kind of inherent contamination, the inks, the tape, the plastic, the caps, whatever the big sorting facilities can't remove. They will then make a product that hopefully somebody wants to buy. And we'll talk about why I say hopefully. Okay? There's always something lost in recycling because of that little contamination. It's never exactly the same material. I'll give you some examples of that. Okay, so we're going to go through each of these steps fast. Okay, I'm not going to be up here for 3 hours. I would apologize for that. Actually, my waste management class is a 3-hour lecture, and I can go on and on and on and on and on. So I have to work breaks into there so nobody falls asleep. Okay, so the consumer. First question, very upfront. I mentioned this yesterday. Who gets to recycle? This is every waste management, this is every material recovery facility in the U.S. Okay, the colors don't really matter. It's just different radii around the facilities. But you can see they're not everywhere. And even big states with lots of people, Texas, for example, doesn't have as many recycling facilities as they should have. And I also mentioned this yesterday. This is not necessarily consistent with where the plastic is generated. The recycling facilities are in wealthy, educated areas primarily. Okay, I have a stat here. Communities near material recovery facilities are 30 to 55% wealthier and 14 to 19% more college educated than areas without. And again, plastic packaging, waste generation is fairly stable across all communities. So the first thing we can do is, in terms of improvements, is better site our facilities. Okay, and address everybody that has this waste. So improvement number 1. This, by the way, as I said, is from a paper that we wrote recently. It was just a couple months ago. 5 locations. The first location, they get serial numbered totes. Every week, the recycling gets picked up. Second location, serial numbered totes, but every other week the recycling gets picked up. Or every week, a different material gets picked up. One week it's cardboard, the next week it's bottles. Then you go to another location, independently negotiate contracts. So you buy a new house, the first thing you do is call all the waste management companies and pick the one that gives you the best rate. Another location, use whatever you want, the city will pick it up. You don't need those serial numbered totes, you don't have to pay the city, you just use your own bin. Next location, you don't get any pickup at your house and you drop off your recycling at a waste transfer station. All 5 of these methods exist in Erie County. Okay? So when we talk about improving recycling, there's opportunities to standardize recycling. That's hard. I'm not saying that's easy. Standardize is an easy word, okay? But if you work for Erie County, you would throw things at me now. Logically, that would improve recycling, but it's very, very challenging to do. There's rural areas where there's miles and miles and miles between houses. Those are tough to fit into a weekly pickup scheme. And it costs a lot of gas to get a big truck out there. So it's a complicated problem, but this lack of standardization is what creates misunderstanding as well. And so we have to be kind of transparent about that. And then finally, education. A lot of municipalities spend a whole bunch of their recycling budget just teaching people what can and cannot go in bins. And that's essential. That's one of the ways that we will improve recycling, is just telling people, you can put your pizza boxes in the bin. We don't care if there's a little cheese on them. This was a huge campaign in Buffalo. That is a lot of cardboard. We eat lots of pizza. I'm from Chicago. They eat more pizza. But this is very important. And even like kids programs. Okay, we had lots of folks from Erie County here yesterday, colleagues that I work with all the time. They are educators as much as they are running numbers on Excel spreadsheets, okay, or regulating. Because recycling requires education. It's why I'm here, right? This is my job. When I speak about waste management, it's just to inform, because we all interact with this system probably 30 times a day. We were talking about it before, I still once a day have to look at something and say, oh, recyclable or not recyclable? It's hard, but we got to talk about it. So education is one of the ways that this will be improved. You all taking what you learned today and telling somebody else about it is how these systems get improved. Okay, now we're on to the totes. You might think the totes, who cares? Well, the big thing is single stream versus dual stream. So when I was a kid, my house had 2 recycling bins, right? One was for cardboard, and the other was for containers, is more or less what the differentiation was. In the late 90s, most municipalities across the U.S. switched to one big bin. Probably most of you today have one big bin. Does anybody have 2? Is anybody dual stream system? So 5 or so hands? Yeah, not many. The reason we went to single stream is because people are lazy, right? The sole purpose was to make it easier. Because everybody thought that if it were a little bit easier, recycling rates would go up. And they did somewhat. Okay, maybe not as much as we hoped, but they did. Now, today, as we speak, many municipalities are going back to dual stream. Because contamination is everything. And if you can remove one material, like cardboard, and sort of outsource that sorting to all of us, that's going to improve the value of everything else. And there's kind of this logic of, okay, people get it now. Those that recycle with single stream aren't going to just be like, yeah, I quit. I'm not doing 2 bins, I'm out. Okay, we all believe in this to some extent, okay? And we'll do it with 2 if we do it with 1. So there's a good chance in the next 5 years your municipality will switch back to dual stream. And that would be why. It's all about sorting, and it's all about contamination, it's all about making the recycled material more valuable. Haulers. I think a lot more than I ever thought I would about trucks these days. Okay, I'm not a transportation engineer. I work with really smart transportation engineers that understand routing and efficiency and how long the truck idles and all of that kind of stuff. But we think a lot about how far these trucks have to travel. Okay, and if there's a way to optimize this. We're working now on tools that a municipality could own just to optimize. You know, for example, do you pick up, if you got one commercial client that has tons of recycling, and then you got miles and miles and miles of residential clients that just have a little bit each. If you go to that commercial client first, you're spending the whole day carrying all that heavy weight around, and you're spending more gasoline, and it's wasting more energy. It's making that recycled material less valuable. But if you route to just flip it, and you pick up their stuff last, well, then you're good. So there's some simple questions here that people are working to figure out, including me. We're thinking very hard about how to figure out the transportation footprint within the waste management industry. You can't see, but this image has lots of dots. And basically, we took every building in New York State Every single one. This building, your house, every building in New York State, and calculated how far a truck has to drive to get to their recycling facility. And then we can kind of optimize and figure out, okay, what if we put a recycling facility here instead? What if we put a landfill there instead? How would that improve this system? We did it for New York State, and then we did it for the entire US. My students are way smarter than me. They're great. Other innovation in haulers, different types of trucks. You know, some areas they have the robot arms. The robot arms mean one or maybe two fewer employees that need to be paid, which means less operational costs, which means more value for the recycled materials. There are conversations about going to electric for these trucks, but they're heavy, they're big, and sometimes they travel far. And so that's a big battery on a big truck, and it's expensive, capital costs, and so there's lots of conversations going on about optimizing the system. Maybe there's small trucks that we can use and more transfer stations, and then big trucks after that, and things of that nature. But the trucks, don't take them for granted. They have a big part in this system. Okay, so now we get to the material recovery facility. It's picked up from your house, it's picked up from commercial clients, whatever it might be. We get to the material recovery facility, and now their purpose is to have one or maybe two streams in and about 8 streams out. So all they do is sort. And they're cool. They're fast. They're perfectly engineered. They're a little smelly sometimes because we don't finish our beer cans or we put deer carcasses in our recycling bins, right? But they're dusty. There's lots of dust. These things are being thrown around. Usually you'll wear a mask if you visit the facilities. But they are fascinating. And I could spend lots of time talking about sorting. But I tried to kind of break this down into as simple as possible, okay? So, the good when it comes to sorting: steel, aluminum, and cardboard, okay? Steel is incredibly easy to separate. It is the only magnetic item in your recycling bin, or at least it should be the only magnetic item in your recycling bin. They literally put a magnet over the line and pull out your soup cans. Lots of value there. Steel's expensive. Steel's expensive to make new. It's easy to remove. It's easy to recycle, right, to turn it back into steel. And it works really well. So there is a single device, a magnet, that works to remove one item, and it does it well. Green. Aluminum, same thing. Aluminum gets separated with what's called an eddy current separator. Okay? It's kind of a reverse magnet. That's how I think about it. So if you see an aluminum line, you'll watch this conveyor belt, and then it'll go to this spinning wheel, and all of a sudden the aluminum will sort of fly over it. It's almost like it jumps up and goes over it. That's because the metal is interacting with this eddy current separator, and nothing else is interacting with it. So everything else falls down, but the aluminum just kind of hops over it into a bin. Near perfect efficiency. It works fantastic. Just like the magnets, nothing else interacts with it. Very easy to remove contamination. One of the reasons why aluminum recycling works so great. Cardboard is a mix of discs and screens. Same with paper, actually. It's a mix of discs and screens and manual sorting. You don't have to break down your cardboard boxes. You can fold them up, but you don't have to rip it into small pieces. In fact, they would prefer it to stay large because a lot of cardboard just gets pulled out before the whole process even starts. It's easy, it's big, it looks much different than everything else, and the process works very well as a result. So all of these, the commonality is that there's a single device for sorting a single material that has a unique property and a lot of end value. That is when recycling works best. Plastic is tough. And the reason plastic is tough is because there's so many of it. There's only one aluminum. Aluminum is aluminum is aluminum. Yes, there's alloys and things like that, but in general, our cans are all the same alloy of aluminum. There's 7 plastics, and they all more or less look the same. I could have a row of all 7 in front of me, and you wouldn't be able to tell me which is which. I wouldn't be able to tell you which is which, unless I touch it and smell it, and maybe not smell it, but touch it and feel it and rip it and that kind of stuff. That makes plastic sorting incredibly challenging. There's a technique called near infrared that they sort of shine a light on the plastic, and it can identify the chemical structure. This is called optical sorting. Super cool. If I had infinite time, I'd pull up YouTube videos and everything else, but you should do that on your own time. It's really, really cool to see. So there'll be this scanner over the conveyor belt. It shines a light on every single item that goes under it, every single one. And it identifies instantaneously which ones are PET and which ones are HDPE. And then a little bit past that scanner will be a series of holes. And in each of these holes, they'll send a pulse of air, just a jet of air, that will shoot it over a wall. And it knows, the system knows how quickly the conveyor belt's going. It knows the exact location of that plastic that it identified as PET. So it knows the precise time that it will go over one hole, shoots out that jet just to get that Coke bottle, and then throws the Coke bottle over a wall. It's amazing. It works great. And this is why, largely, PET and HDPE get recycled pretty efficiently. It's also why you should empty your Coke bottles if you don't finish them, right? If that bottle's heavy, that pulse of air isn't going to do much, right? It's not going to be able to lift it over the wall because it weighs a lot. So it's taking advantage of a unique property of plastic, that it's light, but it's expensive. Again, these places run on the thinnest of margins. Every day is unpredictable. It's not easy for a recycling facility to just throw down, say, $150,000 to install one of these things. I think our facility at Buffalo has, I want to say, 2 of these. And again, we're a pretty big facility. They process a lot of material. If anybody lives in New York City, what used to be called the Sims facility in Brooklyn, right on the water, they have 16 of these. They are the gold standard for recycling plastic in the US because they got a lot of money and they could buy a whole bunch of these things. And they can have one, and then if it gets through that one, they got another one behind it, and they can calibrate it to figure out a different plastic and then use it for that plastic. And if you have 16 of them, which means you have millions and millions and millions of dollars, which nobody has, you can do this. But you need capital. You need support to be able to make that happen. Okay? So I put these in yellow because they can get recycled. They often do get recycled, but not always. Okay? It's a decent system in a lot of places, but not all places. 3, 4, 5, 6, red. In most places, these other plastics in material recovery facilities are trash. And the reason is, even if they can separate them, nobody really wants to buy them. Even if they can get a decently pure stream, which is hard to do, requires manual sorting and things like that, it's a really challenging product to sell. There's just not great markets for it. 5 is sometimes the exception. 5 is polypropylene, often used in like 5-gallon buckets or in cat food containers, kind of those bigger, rigid, more rigid plastics. Polypropylene's like hovering around 0. So sometimes it's above 0 and they can make a little money. Sometimes it's below 0 and they can't make any money or they lose money and it's cheaper to just landfill it. So 3, 4, 6, 7's the mixed plastic. That one's kind of always trash. That's a tricky one to screw around with. But these are the ones that there's opportunities for improvement. certainly. And the improvements come in sorting, and the improvements come in markets. And glass we already talked about. I just put question marks, because glass we don't really sort at these facilities. Usually it's broken and just thrown away. Now, in the papers that I read on a day-to-day basis, the most interesting ones and the most numerous ones are about new improvements in plastic sorting. Ways to do it faster, ways to do it cheaper. This is where AI and machine learning, which I'm sure there's probably a whole week in Chautauqua about AI and machine learning, right? Every year at this point. They have people that just take photos of every item you can possibly think of and train a computer to know what material it's made out of. It's not even chemistry. It's just Coke bottle, PET, yogurt container, this, milk jug, that, piece of pipe, this. And it trains a computer so that when it takes a photo on a stream, it just knows which one it is. And then a robot picks it up and puts it in the right bin. Lots of companies, this one's from a company called Amp Robotics. They're probably furthest along. There are pilot systems of this. There are full-scale systems of this at small facilities. And again, it's expensive. It works, or at least it can work, but it's pricey. This is an academic paper, this thermal barcode. It's basically identifying a unique property about the plastic with chemistry and pulling that material out accordingly. My colleagues work on this over at UB, chemical engineers, mechanical engineers, things like that. So lots of innovation in this space. People understand that sorting plastic, because there's so many of them, because they all look very similar, is a barrier, and they're working on figuring it out. And I think they will, honestly. But the recyclers are going to need a little bit more capital to be able to implement some of these technologies. And we could talk about where that might come from. And last but not least is once it leaves the facility, getting someone to buy it. So the reclaimers will clean it up, but this is harder than it might sound. So the aluminum that you get back is aluminum. They have no problem selling that. The steel they get back is steel. They have no problem selling that. Those are the materials that keep these companies in business. They make a lot off of those materials, and it subsidizes all the other crap. Plastic degrades a little tiny bit. There's a little bit of plasticizer, a little bit of ink, or a little bit of impurity, or the polymer chains get a little bit shorter. And that changes its properties, maybe just a little bit. But you can see this. You as a consumer can see this. I struggled to find a photo, and I wish I had my own. But if you get a Coke bottle now, you'll notice that bottle is not clear anymore. And the day that it turned not clear was the day that they started saying these are 100% made from 100% recycled material. So I don't know if you could see it great, but the top is kind of yellowish, a little bit brownish. And it's because of impurities in the recycled plastic. It's not unsafe. They wouldn't sell it if it was unsafe. But it doesn't look as pretty. Tide did the same thing. You know, Tide is known for their orange material, right? Their orange packaging. That is their brand. They don't want a slightly off orange. That's not their brand. Okay? And so there was a time where I give them a lot of credit for this. They owned it. And they said, when you go to a store, you're going to see a slightly different color of all of our Tide packaging. That's because we're using recycled material. Super cool. Okay? But you can imagine why that's a harder product to sell. They identify with these things. We, as consumers, identify with these materials, these colors, these products. And any change to that may affect their brand. Not to mention the quality of the plastic and things of that nature. Okay? You don't want your car made out of a plastic that's slightly less rigid. Okay? So recycling polymers is challenging. Let's see, I think I got 2 more slides here. Policy will play a massive role here. Okay, I'm an engineer, I like tech, but oftentimes when we're talking about sustainability, technology is not the solution. The solution is people. The solution is policies. The solution is mindsets. There are technological changes occurring, and they are exciting, but policy will play a role here. And these are the three that you're going to see. You probably are already reading about. The first is called extended producer responsibility. New York State has implemented what we call EPR laws for carpeting. There's paint now. Okay, when you buy a can of paint, you pay a little bit more. That's to guarantee that it gets recycled. Other states have implemented EPR for tires, and there's lots of conversation about EPR for plastic. What EPR is a law that the producer of a product is responsible to guarantee that that product gets recycled. Now, what does that mean for you and me? It means we pay more. That's just a reality. EPR is good. It works for recycling. But ultimately, Coke's not just going to eat the cost of having to guarantee that every bottle they produce gets recycled. No, they're going to charge us a quarter more. Okay? And that's a payment that I won't speak for anybody else, would be willing to pay. I think this is an important thing. Paying a little more makes sense. You're going to hear more about EPR. This is already being discussed for plastic packaging in New York State and other places. Okay? So have that one on your radar. The other way to make this recycled product more valuable is to mandate that it be used. If companies have to buy it, they will pay for it, right? And so there's conversations about mandating recycled content in different products. Again, this is tough because that recycled content isn't exactly the same, especially in the case of plastics, as the original virgin material, but it is a conversation that's going on. And the last one is expanding and changing bottle bills. Again, this is in front of us. This is occurring. People are debating this as we speak. So the bottle bill in New York State is fantastic. Materials that you do bottle deposits on have a higher probability of getting recycled. You should absolutely use them, or if you're like me, I just set my cans in front of my house. Somebody that needs the nickel more than me will take them and guarantee that they get recycled. Wonderful. Okay, I'm willing to make that donation to my community. Okay, and guarantee that it gets recycled. But that law hasn't changed in a long time, right? It's still a nickel. When it was created decades ago, it was still a nickel. It's weird to say the bottle deposit has not kept up with inflation, but it certainly hasn't. It's too cheap. It's too cheap. In Canada, it's way more. And it's also too narrow. Wine bottles, why not count them? Other glass materials. Again, the recyclers hate glass. Anything we can do to get the glass out of the stream is fantastic. Let's get those wine bottles out. Let's get those, 375 ml liquor bottles out. Okay, these are standard size containers. They're clear glass. They're easy things to pull out in a bottle deposit. The other thing, and this is not being discussed, but this is my own opinion, there's no reason to have a bottle deposit on beer cans. Again, there is a very efficient, very effective way of sorting those at recovery facilities. And they make them a lot of money. I often, if possible, will leave some of my cans in my regular stream because I want my local recycler to make money off of them, to be able to subsidize some of the harder to recycle stuff. So bottle deposits are going to change, at least in New York. I hope to see them expand into other states. For whatever reason, this has become a very red-blue issue. I'm not totally sure why, because it works and people make money off of it. But this is where we are. And so expect to see changes in all three of these policies over the coming 5 to 10 years, maybe less than 1 year in some cases. Last thing is a rapid fire round, and then we'll have 10 minutes. I talked a little too long. Rapid fire round. Chemical recycling, plastic to oil. I was inspired by Bill McKibben yesterday saying that carbon capture and sequestration is fake. I think he just responded with one word. He just said this isn't real. I will say the same thing about chemical recycling. Okay. Chemical recycling does not make a lot of sense. Almost every facility that has opened in the U.S. has closed. They do not make money. They're not profitable. And if we can sort PET out, sending it to turn back into oil doesn't make a lot of sense. Use the systems we have. If you have complicated mixed streams, there's a very narrow window where chemical recycling makes sense. And in most cases, that's not what we're talking about. So I am not a fan of chemical recycling. Bio-based plastic. You need to be very clear. A bio-based PET is still PET. It just comes from plants instead of oil. That's fine. That's a good thing. I'm all for not making things out of oil. But at the end of the day, it's still a plastic that's hard to sort. It's still PET. So it might do some front-end good, but it does nothing for recycling. It does nothing for recovering the material after we've used it one time. Okay? Not against it, but, from a recycling perspective, not great. Biodegradable plastics. Okay, so you might have heard of PLA, polylactic acid. This is a new thing. We can't sort 7 plastics. I don't know why we need 8. Okay, you can't put these in your home compost bin. They will not compost. They have to be sorted and then sent to a specialized facility. The argument that people will litter and it will degrade is obscene to me. I hate that argument. Okay, the solution to littering is not to make it easier for people or make them not feel so bad about it. Right? So I am not a fan of biodegradable plastics. Most compost facilities hate them because they don't really degrade at the same rates as the food and the other junk that we have in our compost bin. Composting's great. I could talk for an hour about that next week if you want. But biodegradable plastics is a struggle. And then there's legal challenges all over the place. You'll see cases. These companies are getting sued, saying their products get recycled when they don't get recycled. And so just be aware of some of these claims. There's places that are cracking down on language like 100% recyclable. These materials are 100% recyclable, but that doesn't mean that 100% gets recycled. And so they're not lying, but they are misleading, and it's for legal scholars to figure this one out. And people are trying to do that. Okay, thank you. As I always do, closing thoughts: waste less, pursue discomfort, give a damn, and I'm John. Thanks. Let's go. We'll get right into it. Yeah.
One word: styrofoam.
Styrofoam, yeah. Doesn't get recycled, can turn into microplastics. There are specialized recycling facilities that will take large styrofoam. Sometimes you have to pay for them to take that large styrofoam, but that's your best bet with big pieces of styrofoam. You can put them in your recycling bin, I will say. That is allowed, but it will almost guaranteed go to a landfill if you do that.
There's a lot written about getting all the garbage from the oceans. Is any of that recyclable? And how do they do that?
It's the same issue. At the end of the day, now you're sorting not just a recycling bin worth of stuff, but a whole mass of everything. So sure, if there's a plastic bottle in there, they can pull that out, and in theory, that could be recycled. But the economics of going out into the ocean, pulling out a big island, sorting it all out, and creating a useful material at a reasonable cost is very challenging. We shouldn't have a floating island of garbage. That's a bad thing, and we should remove it. But I don't know how much of that would be economically useful.
Do you ever include in your educating how many great products there are, like laundry detergent, soap, cream rinse, shampoo, that comes in cardboard?
Yeah, for sure. And it's funny, when I was thinking about Tide recently, I saw they have a new plastic-free, they call them Tide tiles that they're working with. So these, the brands are almost never at the table. It's hard to get them to come to conferences and things like that, and I get that. But there is good innovation that they're doing. They recognize, that consumers are increasingly wanting this, or at the very least increasingly aware of this, and that they might be able to get some new consumers if they do something interesting, sustainable.
In Florida, we have a waste-to-energy plant, which we always thought was great until we found out it's the second largest air polluter in the county. Now they want to build another one. We don't know if it's better to burn it or put it in the landfill.
Okay, this is another one that I could talk for a very long time about. And in full disclosure, I've done work with multiple waste energy companies. What I can tell you is that from a greenhouse gas perspective, okay, there are other variables out there, but from a greenhouse gas perspective, waste to energy is always better. I cannot create a scenario where there are fewer greenhouse gases emitted from a landfill than from a waste energy facility. And the reason is simple. In a landfill, organics make methane. Methane and carbon dioxide, but there's a lot of methane. And at a waste energy facility, it's only CO2. And when it comes to climate, methane's about 90 times worse than CO2. So even a little bit of methane is real bad. And so landfills are uniquely problematic in that regard. There are other variables, but what I will say is when I teach air pollution, if I want to show the best, the coolest air pollution control technology, I take them to a waste incinerator. They are, at least in New York, I don't know about Florida, they are incredibly regulated. They have state staff that have offices at their facility because they are constantly monitored. They have the brightest, newest, coolest air pollution control technology because they have to. This was not the case in the 80s. In the 80s, these facilities were dangerous. They killed people. Nowadays, it's pretty cool to see what they do. And most other, not that this should totally dictate what we do, but most other developed, wealthy countries burn their trash. We're big. We have a lot of land.
Thank you. Thank you. This was a great talk.
Thanks.
Some food comes packaged and some leftover containers are made of looks sort of like cardboard. It's labeled compostable.
Yeah.
Do those recycle? What should we do with them?
Those, at the end of the day, it's going to be hard for them to get to a compost facility. We're starting to see more municipal level composting. So Buffalo right now, we have a pilot, what do they call it, a beta program or something. So I have a bin, I have a third bin. I have trash, recycling, and compost that gets picked up every week and taken to an industrial compost facility. So those materials I can compost because I know it's gonna go to a high heat, high pressure facility that can handle that material. Your at-home compost cannot, and if you don't have a system that you know is gonna get to an industrial facility, it's not going to happen. So it's probably trash if you don't have that.
Probably trash.
Yeah.
Okay, thanks.
Great stuff.
Thank you.
I appreciated this information on EPR, which I wasn't familiar with. But since the first Earth Day in 1970, there's been talk about creating the lifetime expense of a product in its original price, which goes to your discussion about the cost of recycling and the margins. Is there any hope for any progress in that regard?
We've become pretty reliant on single-use products. So you're saying...
No, I'm talking about that any product, whether it's disposable or not, the cost of either disposing or recycling or the environmental cost of that is included in its original price so that the manufacturer becomes on the hook for its lifetime cost.
I would say
That's never gonna happen.
Yeah, I would say EPR is probably the closest we're gonna get
Okay.
to that.
Yeah. All right, thank you.
Yeah, thank you.
So you kind of broke my heart. I spent a ton of money on these recyclable plastic products.
Okay.
Bags. Can I put them in with the regular bags that I take to the grocery store for recycling?
So they're bio-based bags?
They say they're biodegradable. You've just told me they aren't.
Those
But can I put them in with the other
they
plastics?
definitely should not go in with the other
So
plastics. Yeah, you know, what I will say about that is if it goes, so my dog poop bags are biodegradable, okay? I know that it's gonna go to a landfill. And so I have this decision that I have to make, right? Do I want a plastic bag that's going to compost, make methane and CO2 and get released? Or do I want a plastic bag that's going to last forever, form microplastics, and become a bigger problem that way? It's a not fun decision to make. But that's what the bio bags are more or less making us think about. If you put it in retail return, it's going to mess everything up. So don't do that. I'm sorry.
So the grocery store fascinates me. The produce section in particular.
Yeah.
Everything is now in a clamshell, and if you buy organic, you put it in a plastic bag,
Yeah.
and then you get to checkout, but they won't give you a plastic bag. And now melons are coming in netting.
Yeah, I mean, in the reusable bags that I pull out of my trunk when I go to the grocery store, I have reusable produce bags. And I just package my own. And I probably pay a little bit more because they never know how to tear those bags and whatever if I have to
What
pay a
about all
dime.
those clamshells? Everything comes in now.
Clamshells are tricky too. They're hard to recycle. Black plastics are hard to recycle. There still are materials that are very tricky. If you can avoid it, avoid it. That's unfortunately the best advice with single-use plastics these days.
So is it better to get like a bag of lettuce versus a clamshell of lettuce? Or is it 6 to 1, half dozen the other?
Probably the bag is definitely going to be trash too. That's usually a more rigid plastic that can't go back to a retail return. Grow your own? Is that you don't want to buy lettuce from the grocery store these days anyway, right?
Thank you for this. I'm not sure this question is appropriate for this venue.
Okay.
But I am curious
Pass.
about the difference between cremation and liquidation. I understand cremation is very bad for the environment because of all the chemicals. And then there's a new process, and they have it now in Asheville, North Carolina, where at mortuaries they now have a process called liquefying. And I don't know what happens to that. I mean, are they filled with chemicals and it's still just as bad, or do you have any idea?
I have no idea. I've never even heard of that.
Does
I do know that,
anybody
interestingly, cremation facilities are generally major air pollution emitters,
Yeah.
and they're regulated and things like that. But I don't know anything about
Well,
liquidation.
This lady looks like she knows.
They said it avoids some of the extra heat.
Let's recycle ourselves.
Okay, I just didn't know it sounds like waste to
Yeah,
me.
no, it's a good question. I don't know anything about it, though.
Yeah, thanks so much for spending your time with us.
Of course. No, thanks for having me.
Your talk yesterday, too, and it was really great. You burst my bubble on glass. And so having lived in State College, Pennsylvania, they do curbside separation and separate the glass. Just wondering, what is, the future to improve glass recycling?
Yeah, great question. I think expanding bottle bills will be a big one to include more glass items. And I also think we might, I know New York policy better than most places. And by law, every New Yorker has to have access to glass recycling. So there's been instances where material recovery facilities sent letters to all their clients that said, don't put glass in our bins. It's going to get landfilled. It makes everything worse. You will improve everything else if you don't do it. is illegal. They can't say that. But I could see a world where there's separate venues for glass recycling, like drop-off sites and things of that nature, where it will be more effort, and we're going to have to truck around things that break and make a lot of noise and store it in another bin. But I think that's probably going to be the best. There is some tech that can differentiate the colors, and so the product is more valuable, but it's going to be tricky.
Thank you.
Thank you, everyone. I think we have some closing thoughts.
Thanks.
Before you leave, on behalf of Larry Rizzolo, I want to thank all of you who wrote to OMB and wrote to your congressmen to make clear that this incredibly harmful change in regulations on how grants are made is really going to hurt science. And keep watching this. While some could say that our Congress is currently non-functional, some of the times it's functioning in ways that we almost wish they weren't functioning at all. So, but pay attention to the issue of how we're doing grants for science. Also, I want to recycle some of your money into helping the science group keep doing this. We have a basket back there, and we're going to be posting on our website how you can make tax-deductible donations. The other thing, I'm really committed to us sustaining the Chautauqua Daily. And we've had a wonderful writer this year who's done great stories, but it has the same problem as plastic bottles, and keeping the Daily going is going to take money. You're going to need to keep buying it, and pay attention to those people who want to just make it all digital, because it's going to be actually harder for us older people who are used to carrying paper around to guide us to get guidance from an all digital paper. So keep your eye on the Daily, and let's sustain and recycle it also. Next week, we're going to be talking about some of the tricky things that are happening to science and how we need to take care. And if you don't want to go out in the rain, you can come up and ask John some more questions. And we'll see you next week.